In this tutorial, we'll demonstrate Micro-Magellan's ability to change settings of acquisitions in progress in order to respond to dynamic biological processes. We begin with the example shown here, a 20-hour time-lapse recording of a mouse lymph node. As you can see, the lymph node undergoes morphological changes over the course of the experiment. First, we will demonstrate how to modify a surface during an acquisition to account for these changes. We begin having already explored the lymph node and created a surface to mark its cortex. We will be running a time-lapse acquisition, which images the first 80 microns below the surface of this cortex. We have also set up covariate settings to increase laser power as we image deeper into the cortex. This will compensate for the depth-dependent scattering and absorption of excitation light. We now begin the acquisition and fast forward to the completion of the first time point. At the conclusion of this first time point, we can see that our interpolated surface still accurately tracks the position of the cortex of the lymph node. However, at a later time point, we can see that this is no longer the case. The lymph node cortex has changed shape. With the acquisition paused, we can now modify the surface to reflect the new shape of the lymph node cortex. Right-clicking on an interpolation point removes that point. Holding Shift and right-clicking removes all points at the currently visible slice. Moving slice by slice, we can remove the existing points and add new ones that accurately reflect the new shape of the cortex. Our updated surface will now accurately reflect the new shape of the lymph node. This will update the shape of our surface-defined acquisition volume at the next time point. In addition, it will update the gradient of excitation laser power determined by our covariant pairing. We will now move on to demonstrate an entirely different way we can change settings during an acquisition. Instead of changing a surface, we will define an entirely new imaging volume altogether. The setup here is the same as in our previous example. We've paused our acquisition after collecting a first time point. As we scan through the data, we notice that the bottom half of the lymph node contains most of our labeled cells of interest. We will now create a new surface to mark this area so that we can run subsequent time points focused only on it. After renaming this surface to keep track of it, we can swap it in as the XY footprint for the current acquisition. We also change our settings so that instead of imaging only the first 100 microns below the surface of the lymph node, we collect the first 160. After running the acquisition for an additional 5 time points, we can see that we've zoomed in on this small subregion where most of our cells of interest occur. Playing back the data we've collected in 3D gives an even clearer view.